So, good morning, everyone. My name is Rahil, and the topic of today's webinar is AWS Hybrid Network Architecture. We're going to discuss more about hybrid connectivity options and how hybrid connectivity offerings from AWS, how you can establish hybrid connections, network connections on AWS. So, hope this session would be informative. And we'll also have a Q&A session at the end of the webinar. So if you have any question, please note it down and I'll go through those questions one by one after this presentation. All right, so we'll start. So what is hybrid? If we ask, if I can ask you, what is hybrid? So hybrid, as we know, it means cross connectivity, especially if we have infrastructure on AWS and if we have a corporate data center. We want to connect both the data center, which is like our infrastructure in cloud, and our corporate data center together. And we can have multiple data centers, right? We can have one data center in location 1 and one can be in location 2, other can be in one public cloud, which can be AWS, and other can be on another public cloud. So we can have a variety of infrastructure running in different locations. So here in this picture, as you can see, we have an AWS VPC, and we have some of the instances which is deployed in public-private subnet, standard VPC configuration, standard routing table via internet gateway, right? And we also have our corporate data center located inside our on-premises, right? And then the question is how we're going to connect both the locations and how we can guarantee reliable, stable connectivity between our on-prem data center and AWS virtual private cloud. So we'll explore that options in the upcoming slides. So the answer is first option could be your AWS Site-to-Site VPN connection, where we establish a site-to-site VPN connection between your VPC and corporate data center, right? So site-to-site VPN, as you know, is a fully managed and highly available VPN termination endpoints at AWS end. So one end of the VPN tunnel will be terminated at AWS end, and the other end can be terminated at your edge device, right? So with each VPN connection, you'll have two VPN tunnels terminating in different availability zones. So this means it will be highly available, right? You'll have two peer IPs. So you can use both the peer IP to guarantee a highly available VPN connection. And but these out of those two peer IPs, only one will be active, another will be in passive state, right? With site-to-site VPN, you can also have a tunnel with AES 256, SHA-2, and Data's DH group is also supported. Site-to-site VPN also support IKE v2, NAT-T, and it is charged per hour. So let's say if you have a site-to-site VPN running for 1 hour, you're only going to incur cost for 1 hour. Now, how does it fit in, and what are the possible options for site-to-site VPN? Let's explore that. We have basically two options for site-to-site VPN. One is static and the other one is dynamic. What is static? Static is policy or route based, right? You can have a policy or you can define a route and you can route all the traffic through static routing. So the routes has to be added in a static way. So you define static routes inside your connection. It supports authentication. You can have pre-shared keys. Now you can also use certificate-based authentication. This is also supported now. With dynamic, it is route-based only, so you do not have policy-based routing. In dynamic, it supports dynamic routing protocol like BGP, Border Gateway Protocol, and it supports authentication like static. So you can have pre-shared key or you can have certificate-based authentication for your IPsec VPN tunnel, right? So let's explore the steps of setting up VPN, site-to-site VPN connection using AWS Virtual Private Gateway. So if we talk about Virtual Private Gateway, it is a gateway that will be attached to your VPC in AWS, and this will be responsible for terminating the VPN connection at AWS end. So we'll see that in the upcoming slide. So the first step would be to create a virtual private gateway inside your VPC, and then you have to attach that virtual private gateway to your VPC. That would be the first step. So it's pretty simple. The way you create virtual private gateway is by going into the AWS console. You give a name for your gateway, and if you want to use a custom ASN, you can give your ASN, and a gateway will be created. Very straightforward. Now in corporate data center, you'll also have a customer gateway, which is your perimeter device, or which is where you're going to terminate VPN connection at the corporate side or the client side, right? So you need to add the customer gateway also on AWS. And this is also very simple. You give a name for the customer gateway. You define routing, whether you're going to use dynamic or static routing. You give the BGP ASN a number, and you give the IP address of your gateway, the public IP address of the gateway. Now at the end, you can also see there is an option for certificate ARN. So with certificate ARN, you can have authentication based on certificates, right? So when you have a certificate ARN, you are not required to specify IP address. So IP address becomes an optional. It's not needed when certificate is used, because we are using certificate based authentication. Where if you are not using certificate, you must supply IP address of the customer gateway, which is your public IP of your edge device, or edge router, or wherever you're terminating, maybe firewall, the IP address on the outside interface of the firewall. That would be your gateway, the customer gateway, right? Now once we have that, we're good to establish a VPN connection, right? So you can establish one VPN connection. With that one VPN connection, you'll actually get two peer IPs, and you can establish two VPN tunnels on terminating at one customer gateway, right? And then you will add a static route. So this is also very simple. The way it is, you just create a VPN connection, and then you will add what gateway you want to use, what customer gateway you want to use, right? And then a VPN connection will be established. Right? You also are required to do the configuration on the on-premises data center. So let's say if you have a FortiGate device in your on-premises, you can download the configuration from AWS console for FortiGate device and configure your edge device uh, based on the configuration that you downloaded from the console, and the tunnel will come up, right? So now we have set up a VPN connection, and we know how to route traffic, right? How to reach basically our VPC. But you have deployed an EC2 instance, let's say, inside your VPC, and it doesn't know how to reach to your corporate data center because it doesn't have the route, right? So the first thing would be to add a route to your EC2 instance. And as you know, EC2 instances are deployed in a subnet, and each subnet has a routing table. So you are required to add the route for the VPN connection, right? You will route everything to the virtual private gateway. So let's say my address or my IP range for corporate data center is 172.16/16, right? So what I'll do, I'll route all the traffic to 172.16/16 to my virtual private gateway, which is attached to my VPC. And you know that virtual private gateway has a route. We already have a VPN connection established, and it will be able to we will be able to connect our instance to corporate data center. So we need to add a routing table. That's mandatory. right? So once we add the route, this is what happened. So our instance will reach out to virtual private gateway. Gateway already has a tunnel established, right? And there will be two peer IPs. So you will select your preferred route or your preferred tunnel, right? And you will be able to reach out to the customer gateway. You see, one tunnel is always preferred, and with that tunnel you will be able to reach out to your customer gateway. You have an option to uh, use both the tunnel, use both the peer IPs, and you have the tunnel to use either one of the peer IPs, but it is always recommended to use both for high availability purposes. And one VPN connection, as you can see, will have two VPN tunnels. One VPN tunnel can give you up to 1.25 gigabits per second of throughput, right? Now, what will happen if we have multiple VPCs? Because in the previous diagram, if you see, there is only one virtual private cloud, only one VPC. What if we have multiple VPCs? So if we have multiple VPCs, we have to establish multiple VPNs, multiple site-to-site VPNs. So each VPN, as you know, will have two tunnels. So if, let's say, we have 4 VPCs, we'll be having total of 8 VPN tunnels, right? For if we go with high availability, that's a lot of work, right? So you have 4 VPCs and you established VPN connections for all the 4 VPC, and it will terminate at the customer gateway. And if we go with high availability, we'll have 8 VPN tunnels. So this is how it will look like. But the question is, can we simplify it? The answer is yes, we can simplify it, and we'll see how we can simplify it in the upcoming slide. Now, if we need cross connectivity, and let's say if we have multiple customer gateways, or if we have multiple edge devices in the corporate data center, then multiplied by 2, total we have 16 VPN tunnels, right, for 4 VPCs. If we want to connect to all the 4 VPCs from our corporate data center, we'll have 16 VPN tunnels, which is huge, by the way. So 4 into 4, 8 VPN connection and 16 VPN tunnels, large number, right? And it can grow, because in AWS, if you go with multi-region approach, you'll have even more VPCs. Now, how can we simplify it? Because to manage all those 16 VPN tunnel, it can be challenging. Now, how can we simplify it? The answer is through transit gateway. Now, what transit gateway does is it simplifies our VPN configuration. So we are only terminating our VPN at the transit gateway, not individually at the virtual private gateway, if you remember. So here what we are doing, we'll attach our VPC to the transit gateway. So if we have 4 VPCs, we'll have VPC attachment to the transit gateway, and then we will terminate our VPN connection at the transit gateway. And the transit gateway know how to route traffic, right? So it will be able to route our traffic to respective VPC. So the bottom line here is that instead of terminating our tunnel at the virtual private gateway, if we have multiple VPCs, we can very well make use of transit gateway, and we can terminate our VPN connections at AWS transit gateway. And site-to-site connectivity can be established. So it, on the customer end, it will be pretty much the same way you will add the customer gateway. The only difference here is we are routing everything to the transit gateway, and the VPCs will have an attachment to the transit gateway. So how it works, let's say you have a VPC with 10 IP range, 10.0.0/16. That's your VPC. So what we will do, we'll add a route for our corporate data center. Corporate data center IP range, as you can see, it's 172.16.0.0/16. It's just an example, but let's imagine you have a CIDR at the data center, which is 172.16.0.0/16. So what we are going to do, we're going to add a target as transit gateway. So instead of, if you remember in the previous slide, we were routing everything to virtual private gateway. Now we are routing traffic to our corporate data center to our transit gateway, right? And transit gateway will have an attachment. So uh, it can be attached to all the VPCs, and basically you will also have an attachment, and you can terminate your VPN connections at transit gateway, as you can see in this snippet, right? The important thing here is one VPN connection will have two VPN tunnels as usual. So even if we are terminating at the transit gateway, we do get high availability. We do have two peer IPs, and one VPN tunnel can give you up to 1.25 gigabits of throughput. So pretty much the same. Instead of using virtual private gateway, we are using transit gateway. That's the only difference. Now, what if you have multiple customer gateways or multiple edge devices? Similarly, we'll have four tunnels and two connections. So one connection will terminate, let's say, at the customer gateway 1, and other connection will terminate at customer gateway 2. So we will have two VPNs terminating at customer gateway 1 and 2, and the other end would terminate at the transit gateway. To get high availability, we'll go with again two tunnels per connection, so it will be four in total. Now we also have direct connect, right? So let's say if you do not want to go with a VPN approach and you want consistent network connection and consistent bandwidth, then you can go with direct connect. Now what is direct connect? Direct connect gives you dedicated network connection to AWS, providing consistent performance and reduced bandwidth cost. So you can really reduce your bandwidth cost, and you have a consistent high performing network connection to AWS from your on-prem data centers, right? So here we are completely eliminating site-to-site VPN, and we are going with direct connect. Now let's understand through a diagram how will it look like. So one end you will have AWS global infrastructure, global network, and the other end you have corporate data center where you have your network, your internal network, private network, which is 172.16.0.0/16, and you'll have an edge device. In this case, we'll call it as a customer router, right? So first thing, what we need to do, let's say if we want to go with direct connect, first thing what we need to do, we need to create a direct connect connection, right? So we'll give it a name. As you can see in the slide, it's very simple to create. We'll give it a name. We'll call it my direct connect, or whatever name you want to give. We'll select the location, right? And there are multiple locations in UAE. We also have direct connect partners, so you can select locations based on your geography. But in UAE also you have direct connect option. Then we'll select sublocation, and we'll select the port option. Port option, basically it's your bandwidth, how much bandwidth you would need. So whether you want to go with 1 Gbps connection, or whether you want to go with 10 Gbps connection. And one important thing, let's say if you want to go with lesser bandwidth, let's say 100 MB connection, right? So you cannot use direct connect. You have to use direct connect with partners. For example, you may have to go with Equinix. Equinix has a connection with AWS, so they'll do all the peering for you. So if you have a sub 1G connection bandwidth requirement, you have to go with direct connect partners, which can be Equinix, maybe Etisalat. So they do have direct connect peering. But let's imagine you have a desired bandwidth of 1 Gbps, so no need to go with partners, you can directly go with AWS in that case. So port speed, as you can see, we've selected 1 Gbps. Once this is done, our our direct connection would be set up, right? And if you see, there will be a direct connect location where we'll have AWS router and we'll have customer router. Customer router is your own router sitting in the direct connect location, and it has to be configured. There has to be pairing done between customer router at direct connect location and your router in your corporate data center. All the pairings and everything will be done. Backend pairing to AWS will be taken care by the direct connect provider, right? And you can also have up to 4 interfaces in a linked aggregation group. So if you want to use lag, you can have up to 4 interfaces in lag. So this will really aggregate all the connection, and you'll get higher bandwidth. Now with that, let's say you have also a VPC set up in AWS, and that VPC has a CIDR of 10.0.0/16. And this VPC, of course, will have a virtual private gateway. This gateway will be attached to the VPC. So what we can do in the Direct Connect interface, we can have a private virtual interface with BGP routing, or you can also have static routing if you want. And we will create a connection from Direct Connect location to your VPC. So you see here we are completely bypassing IPsec configuration, and all we are doing is we are doing an internal peering, or we are creating a Direct Connect connection, right? So private virtual interface, we'll see in the upcoming slide. There are 3 types of interfaces. You can have private virtual interfaces, private VIF. You can have public VIF, and you can have transit VIF. Private VIF basically you will use to access all the internal AWS resources, like whatever resources you're going to deploy in VPC, you will access it through private virtual interfaces. Public virtual interfaces will be used to access external AWS services like your S3 or your DynamoDB, let's say, which is outside your VPC, right? So here in the Direct Connect location, we've established a connection via private virtual interfaces, right? And how now, instead of we also have to add a route for our subnet, which is deployed inside the VPC, and the routing uh, will be similar. So 10.0.0/16 is our VPC, and all the target will be local. So VPC in itself knows how to route traffic. But for the corporate data center, we are routing all the traffic to virtual private gateway. And virtual private gateway, if you can see in the slide, it has a connection to our customer router sitting in the Direct Connect location. So it knows how to route traffic. Now we discussed about interfaces, right? We discussed about private VIF. Now let's explore them in details. So there are like 3 types of interfaces supported by Direct Connect. One is private VIF, used to connect to AWS VPC, Amazon VPCs, using private IP address directly or via Direct Connect gateway. We'll come to the gateway. We'll discuss about the gateway. Gateway basically gives you capability to use multiple region for Direct Connect. So if you have multi-region deployment, you're using multiple AWS regions, then you can use Direct Connect gateway. We also have transit VIF, which is used to connect to transit gateway via Direct Connect gateway. And you also have public VIF, which is used to access all AWS public services using public IP address. This could be your S3, DynamoDB, and other services. So all virtual interfaces are 802.1q VLANs, pretty much standard, with BGP peering. So important thing to remember, these are 3 types of interfaces available with Direct Connect: public, private, and transit. Now we'll see what is private VIF. We already saw that in our previous slide, but let's look at the private VIF in context with Direct Connect gateway. So as you can see in the slide, we have 2 regions. So one region with 2 VPCs, 10.0.0.16 and 10.1.0.0/16. The other VPC, 10.2.0.0/16, is in another region, right? So the good thing is with Direct Connect, you can also connect to multiple regions. So to do that, we need a Direct Connect gateway. So instead of terminating, instead now here, our customer router, which sits in Direct Connect location, will be connecting to Direct Connect gateway instead of connecting to the virtual private gateway, right? So with this Direct Connect gateway, the backend, it can connect to any of these virtual private gateway which sits in our infrastructure. And since we are using a private virtual interface, so we'll be able to connect to our VPC resources via private IPs, not with the public IPs. Everything, as you can see, it's pretty much the same, except the fact we have two regions here, and we are using Direct Connect gateway, and we are not terminating we are not establishing connection from our customer router sitting in Direct Connect location to virtual private gateway. Instead, we are connected to the Direct Connect gateway. Now, what is allowed? So in this case, you have connectivity allowed from VPC to your corporate data center. So if you have two VPCs, they will be able to connect to your corporate data center, but one VPC cannot connect to other VPCs. This is not allowed. To do that, you need VPC peering. This won't be allowed through Direct Connect, right? But your VPCs can connect to your corporate data center. This is all allowed. Now we'll talk about transit VIF. What is transit virtual interfaces? So the diagram is pretty much the same. If you can, I'll just go through the previous slide. So if you see here, we have virtual private gateways, right? And our customer router connects to the Direct Connect gateway, and the Direct Connect gateway in turn has a backend connection to the virtual private gateway. But in this slide, we have transit gateway, and if you remember from our previous slide, transit gateway can be used to simplify VPN connections, right? So here, instead of virtual private gateway, we're using transit gateway, and transit gateways will be attached to the VPCs, will have a VPC attachment. And now we are using a transit virtual interface. So our customer router sitting in Direct Connect location will connect to the Direct Connect gateway, and in turn, the Direct Connect gateway will have a backend connection to the transit gateway. And this is possible only because we are using a transit virtual interface, right? So pretty much the same, except the fact we are replacing virtual private gateway here with transit gateway. And this makes sense because if we have multiple VPCs, transit gateway will simplify our connectivity requirement, right? On the right hand side, everything is the same. We still have one customer router, and in the Direct Connect location also we have AWS router, customer router, which has a internal peering mechanism, and pretty much everything is the same except the fact we are replacing virtual private gateway with transit gateway, right? And what is allowed here? The allowed connection is VPC to your corporate data center. You can connect. This is allowed, but you cannot connect one transit gateway with another or one VPC with another, as we discussed previously, because for that you need VPC peering. This will not be allowed through Direct Connect. Got it? Pretty much the same, except the fact we are using transit gateway instead of virtual private gateway. Now, what is public VIF and how to use public virtual interfaces? So we have services, global services available from AWS such as S3, CloudWatch, DynamoDB. This is actually not deployed in a VPC, and it might not have private IPs. For S3, for example, it's a global service, right? It will not have a private IP. You cannot access S3 by private IP. You need to access it with the help of an endpoint, public endpoint, right? So for that, we would need a public virtual interface. So the diagram would be pretty much same. We'll have Direct Connect location. We'll have our customer router sitting in the Direct Connect location. We'll have AWS router. Both would have a connection. Both will be paired. Our customer router in corporate data center will be paired with customer router in a Direct Connect location. And we are creating a public virtual interface in our Direct Connect so that we can connect to the services, the AWS global services, which has a public endpoint. So even that also can be reached via Direct Connect. So you'll have good performance and you can reduce your internet bandwidth as well in this case. With public virtual interfaces, you can also have AWS VPN connection, like normal VPN connection, which we discussed in the upcoming slide, and you can do a mix and match. So you can have AWS Direct Connect, public VIF, and VPN connection, basically AWS VPN, standard IPsec VPN terminating at the customer router. We can have that setup. You can do a mix and match. This is completely allowed. Similarly, if you have a transit gateway, you have multiple VPCs, you can have AWS VPN connection terminating at the transit gateway, and you can continue to use AWS public virtual interfaces for S3, CloudWatch, DynamoDB, and other public services from AWS. So it's very much possible to do a mix and match. Now, few things to remember about the interfaces available in Direct Connect. With private virtual interfaces, you can have up to 10 VPCs. This is very important. So you can have up to 10 VPCs support with private VIF. This can change. So this is as of like December 2019 or Jan 2020, but this can change. As of now, it's 10 VPCs. Uh, Private virtual interfaces supports up to 10 VPCs. Right. Transit gateways, virtual interface supports up to 3 transit gateways, and public virtual interfaces probably you can connect to any of the public services available on AWS. Direct Connect Gateway allows for connecting resources in any region. So if you have resources in any region, you can connect using the Direct Connect Gateway, except China. So China, we have a restriction for China. Otherwise, all other AWS region can be connected via Direct Connect gateways. Right. Now let's look at the high level picture, and just to understand the complete topology or the complete network diagram, if you want to say, how will it look like with Direct Connect. So we have 3 regions. We have resources deployed in 3 regions, right? Each regions will have multiple VPCs, right? And each VPCs will have virtual private gateway. And we can also have a transit gateway in between to simplify our VPN connections. We can attach transit gateway to multiple VPCs. Then we will have our Direct Connect gateways, and Direct Connect gateways will, let's say they have we are going with private virtual interfaces. So you can have 50 per Direct Connect connections. So if you have a Direct Connect location, you can connect up to 50 Direct Connect connections. So remember, so all of the lines are in yellow. These are all Direct Connect connections. So you can have up to 50 connections. You can use gateways, you can use transit gateways. It's up to you, but 50 Direct Connect connections are supported with private VIFs. Right. So what it delivers full mesh connectivity. So no region left untouched. So we will be able to connect privately to all the regions. So it's a full mesh connectivity. No transit gateway processing cost for data transfer between AWS and on-premises network. So let's say if you are using transit gateway IPsec VPN connection, there is a cost for data transfer, right? Between data going in and out, there is a cost. But in case of Direct Connect gateway, you are not paying for the data transfer that occurs between AWS and on-premise via transit gateway. So there is no cost for transit gateway processing. And you can have 100 routes per private VIF. So it's a pretty significant number. So I think you'll use probably less than 100 routes per VIF. Consideration, well, private VIF and Direct Connect gateway requires uh, like it supports up to 10 VPCs. So if you have more than 10 VPCs, you might have to use multiple interfaces or multiple direct connections, or you might have to use two direct connect gateways. So up to 10 virtual private clouds, VPCs, are fine. VPCs needs different routes via transit gateway and virtual private gateway. So they should have a different route. That's another consideration. Now let's talk about transit gateway, direct connect with VPN backup. So as we discussed in our previous slide, so you can have direct connect connection, right? Where your customer router will sit in the direct connect location, will have a interface called transit virtual interface, and you can terminate, you can get a private connectivity via direct connect gateway. Now, as a backup, you can also have a IPsec VPN connection terminating at your transit gateway. So let's say if for some reason your transit virtual interface is down, or if it is not responding, you can still reach out to your customer router, which is located in customer corporate data center, here on your right hand side, via IPsec VPN. So this is a backup strategy that many enterprises adopt. So Direct Connect itself will give you stable, reliable bandwidth, dedicated bandwidth. But in some cases, let's say if your virtual interface is down by mistake or by accident, if it comes down, then you have an alternate route via IPsec VPN, which is your backup. So you can connect to your corporate data center via VPN connection, via site-to-site VPN connection. And again, this VPN connection will be terminated at the transit gateway. This is for a very big infrastructure when you have, multi-region deployment where you're using multiple region, your customers are located across the globe, and you want to give a good performance to your customers. So you deploy your application in multiple regions. You have different VPCs in different region. Then this approach works very well. This guarantees almost 99.99% uptime, where you have a IPsec VPN backup and also you have a transit virtual interface. So we are mix and match. We are doing a mix and match, right? Along with Direct Connect, we are using a VPN backup. Now, what are pros and cons, what it delivers, and what should we consider? Let's discuss that. So, it delivers a backup for direct connection. So, in situation where our interface is not responding, or if we have an outage, we can simply use the VPN connection as a backup. So, our connectivity to on-premises will be up and running with VPN backup. And it is simple to provision. So you can quickly provision the IPsec VPN and the virtual private interface, and you can have highly available connectivity. So some of the consideration which we have to keep in mind: we have to avoid advertising more specific prefixes over the VPN path, because otherwise we may cause conflict. So let's say if we are giving a broad address range, if your corporate data center is 172.16.0.0/16, and we are adding two routes, right? 172.16 routing via transit virtual interface, or the gateway, direct connect gateway, or and 172.16 routing via the virtual private gateway or transit gateway. So there is a confusion. In that case, we are causing confusion, and since the IP range is the same, so subnet, there will be confusion like which route I have to choose. So it's very much recommended to use a different CIDR. So let's say you can drill down to specific subnets. So you can give 172.16.1.0/24. So you're not using an overlapping subnet, but instead you are using a different subnet, and you're routing traffic to transit gateway with different CIDR. This will avoid, conflict. You can also have multiple tunnels. You can also have multiple tunnels. So, for example, in transit gateway, where we establish one Site-to-site VPN connection, you can have up to 2 VPN connection as we discussed previously. So it's always recommended to use both the connections, use both the peer IPs. So multiple tunnels required to match capacity of 10 Gbps direct connection. So this is the requirement. So the capacity requirement is 10 Gbps for direct connect, right? All right, guys. So that's it from my side. So do you have any question? If you have any further question, you can just reach out to me and I'll be happy to answer your queries. All right. Thank you so much, guys. So
All
I'll
right.
stop the sharing now.
Yes. All right. Thank you so much, Rahim. Thank you guys for
You're
attending.
welcome, Jimmy.